Welcome to another Chapter 6 video. This is again dealing with the sampling distribution, and we're going to look at those conditions that I mentioned in the previous video. When we deal with just any distribution, whatever type it happens to be, we are going to want to determine the X-bar distribution so that we can decide what type it is, whether we can use the normal distribution for it. So there are three basic scenarios. The first, if you have a X distribution that is normal, that immediately tells us that the sampling distribution is normal. No other requirements are needed. And if we have a mean in the X distribution of 50, then the mean in the sampling distribution is also 50. And from the previous video, that's always the case. We have a standard deviation of, for example, say 4, then the standard deviation of our X-bar sampling distribution is that standard deviation of X over square root of n, which is 4 over square root. We have to know what that n is to make that calculation. Let's say that it is 25. So over 25, that would be 4/5, which is a 0.8 or 0.80. So that would be the first case scenario. A second case, we just have any type of distribution at all. Just a collection of data points. We don't know if it's normal, we don't know if it's Poisson, we don't know if it's binomial, it's just a collection. With that, we do know that we will have an X-bar distribution. We're going to need more results, though, to decide what comes over. The mean stays the same. That won't make any difference. If we assume this same standard deviation over here, standard deviation of our sampling distribution depends on our sample size now. If n is greater than or equal to 30, we will get to state that that is in fact normal. If it's not, then we won't have any clue. So let's state, for example, that n is, say, 36. Then again, we have standard deviation of x over square root of n. So 4 over square root of 36, which two place values beyond, is a 0.67 for our standard deviation. So those are the cases where we will be able to use the standard normal to do calculations and probabilities. The third type of scenario is when we have an X distribution. We are going to have an X-bar distribution of some sort. This X will have a mean, say 50. Then our mean of X-bar will also be 50, regardless of what happens. If we have a standard deviation of x equal 4, but if we have a sample size of 25, this one is less than 30, so this is not normal. It's just some type of a distribution. We don't know that it's normal to begin with, and our sample size is small. So our standard deviation is unknown. We can't use that formula to calculate its standard deviation. Scenarios that we're going to be looking at typically are we start normal, we get to go to normal. So if it starts normal, it stays normal. If n is greater than 30, we get to use normal. Those conditions let us use the standard normal table for the sampling distribution. If it doesn't meet one of those two things, we can't use the standard normal